Hello, today we're going to be talking about how to make height of burst adjustments for illumination rounds. Topics we'll cover are the optimal height of burst for Illum, how to make height of burst corrections if the flare burns out during descent, how to make height of burst corrections if the flare burns out on the ground. Materials you'll need for this class are the ATP 3-09.30, your coal-for-fire clipboard, and writing materials. References for this class are the .30 pages 6-13 through 6-20. Cover all information on illumination, including how to call for fire and adjust illumination rounds. Table 6-13 will be important to us. You can find that on page 6-14. You'll also be looking at paragraph 6-69 through 6-71, located on page 6-17 in your .30. For any additional information on adjustment of Illum, you can look in the Adjustment of Illum slide deck located in your student drive. Primarily for this class, we're looking at slides 3.1 through 3.6. Before we make any actual height of burst corrections with an illumination round, we have to understand what the optimal height of burst is for Illum. In your .30, page 6-17, paragraph 6-69, it reads, "The proper height of burst allows the flare to strike the ground just as it stops burning." So what it's saying here, right, is we want the flare to open at a height where it will strike the ground and stop burning immediately. Okay, so as that flare comes down, and it will vary due to the individual round, right, the individual flare and parachute, as that flare bursts, it should stop burning as soon as it hits the ground. All right, I continue on paragraph 6-69. Make any height of burst corrections in multiples of 50 meters. Variation in time of burning between individual flares make any finer adjustment of the height of burst impractical. Again, what it's letting you know here, right, is due to variations in those individual rounds and the flares and parachutes, close enough is good enough for Illum. So we will make all of our height of burst corrections for Illum to the nearest 50 meters. If you look at your call for fire clipboard, you will also see down in the bottom right hand corner that it tells us that our minimum height of burst correction for Illum is also 50 meters. So should make it easy to remember. You'll always express your height of burst correction, that up or down correction, to the nearest 50 meters, and the minimum for Illum is also 50 meters. So now we should have a pretty good picture of what our optimal height of burst is for an illumination round. We want that illumination round to burst, and then the flare to burn all the way to the ground, and then stop burning when it hits the ground. So what do we do if the round burns out, if that flare burns out on the descent? All right, so on its way down, and the flare burns out before it touches the ground. Well, we'll have to make a downward height of burst correction, and now we'll discuss exactly how you'll do that. We're just going to look down the page here at paragraph 6-70, which reads, "When burnout occurs during descent, estimate the height of burst correction from the height of the flare when it burned out. When visibility permits, measure the spotting, height of the burnout above the ground, with binoculars. Multiply the height of burst spotting in mils by the observer target factor, right, your OT factor, to determine the height of burnout in meters. Express the height of burst correction to the nearest 50 meters and send as a down correction." So now we'll go ahead and take a look at what that looks like visually. So as our illumination round descends, we're going to be watching through our binoculars, right? And we're going to see a reticle pattern that looks something like this. A reminder that each graduation here represents 10 mils. 10 mils. So we see the illumination round burst somewhere up above our binos, and we watch it drift, right? We're keeping this crosshair right on our target. We're watching this illumination round descend to the ground, and it burns out right here at the 7, meaning it burned out 70 meters above, 70 mils above the target or above the ground, right? So we're going to record that here. Now we need to multiply this by our OT factor. So we see here that our target distance is 1/700 meters. That gives us an OT factor of 2, right? We're going to express that up to 2, and we're going to multiply this out. So we get 70 mils multiplied by 2 is going to give us 140 meters. Now we know for illumination, right, that optimal height of burst puts that round burning out right on the ground. So all we're doing here is adjusting that flare so that it burns out as soon as it touches the ground. But we have to express this, right? All height of burst corrections for illumination are expressed to the nearest 50, so this will express out to 150. Now, because it's too high, we make this a down correction. So our final correction here is down 150. We'll look at just one more example for correcting height of burst when the flare burns out on the descent. So here, again, we see the reticle pattern. We have our target distance of 2,900 meters, and we see our flare burst here, and it descends and burns out right here at this 4. Again, that tells us that the flare burned out 40 mils above the ground, right, or above our target. Now we multiply by the OT factor, distance 2,900. That's going to express to an OT factor of 3. So we multiply 40 by 3. That's going to give us 120 meters. Okay, and now again we have to express this to the nearest 50 meters. All height of burst corrections for a loom are to the nearest 50 meters. So that will express to 100 meters. Our correction then would be down 100, and that's what we would transmit to the FDC. So to recap, height of burst corrections for burnout on descent, we're going to get our spotting, right, where above the ground in mils that flare burns out, in this case 40. We multiply it by our OT factor, in this case 3. We express to the nearest 50, and we send as a down correction. Now we'll discuss what to do if the flare burns out on the ground. So we'll reference paragraph 6-71 in your .30, which reads, when the flare continues to burn after it strikes the ground, a correction is required to raise the height of burst. The length of time in seconds that the flare burns on the ground is counted and multiplied by the rate of descent. It says here, see table 6-14. That's actually table 6-13, found on page 6-14. We'll jump over there in just a few seconds. And then express the product to the nearest 50 meters and send as an up correction. So the bottom line is we're going to see and count how long that flare burns on the ground. And we're going to multiply that number by the rate of descent for the particular round. And we'll find that in table 6-13, which we'll look at now. In table 6-13, when dealing with height of burst, there's really only a couple columns we're going to be interested in here. So on the far left side, we have howitzer or mortar. Next to that, we have projectile. And then at the far right-hand side, we'll see rate of descent in meters per second. Those are the 3 columns we'll be using when dealing with height of burst corrections, specifically when the flare burns out on the ground. So whenever you're shooting a loom, it's your job as the FSO to know what type of projectile the firing unit has. In this case, we'll say that we are shooting 155 millimeter, and that the projectile they're using is our standard visible loom, Mike 485 Alpha 2. So then we'll take that all the way to the right-hand side, and we'll see that Mike 485 Alpha 2 descends at a rate of 5 meters per second. Back at the whiteboard, we note that our projectile is Mike 485 Alpha 2, as we discussed. In table 6-13, we determined that its rate of descent is 5 meters per second. So now we watch the flare burst and descend to the ground, and it continues to burn. So after it hits the ground, we begin counting or keeping track on our watch until it burns out. And we determine that it burned on the ground for 2-3 seconds. Determine it burned for 2-3 seconds. We'll then just multiply that by our rate of descent, 5 meters per second. Those units will cancel out, and what we'll get is 115 meters. So what that's telling us is that this projectile needs to burst 115 meters higher than it did so that that flare burns out as soon as it touches the ground. But as we recall, all height of burst corrections for a loom must be expressed to the nearest 50 meters, which in this case would be 100 meters, making our correction up. Because it was too low, we're going to go up 100. And that is what we will transmit to the FDC, up 100. For our next example, we'll jump back over to table 6-13. This time we'll say we're shooting 105 millimeter, and the projectile we're using is the Mike 314 Alpha 2. So we'll carry that row all the way over to the right-hand side, and we'll see that the rate of descent is 10 meters per second. This time we're using projectile Mike 314 Alpha 2. We pulled the value 10 meters per second for its rate of descent. So the projectile bursts, it begins descending to the ground, it hits the ground and continues to burn. You start counting. Projectile burns out, you determine it burned on the ground for a total of 13 seconds. You multiply that by the rate of descent. So multiply that by 10 or 10 meters per second. We get 130 meters, and we have to express that to the nearest 50 meters, which gives us in this case 150 meters, and we send that as an up correction. So we transmit to the FDC up 150. That will conclude our video for today. So today we went over how to adjust your height of burst on an Illume round, whether it burns out on the descent or if it continues to burn once it hits the ground. If you need more work on this, there's some examples in your dot 30. Again, that Illume section is pages 6-13 through 6-20. For adjusting height of burst, you're looking at page 6-17 in your dot 30. Information on that can also be found, of course, in your Illume slides on the drive. For adjusting height of burst, you're looking at slide 3.1, and it continues from there. Thanks for watching.